All right, class. I had someone send me a question concerning lesson 4.2. And if you look in your textbook, the title of chapter 4, lesson 2 is Antiderivatives as Area. Now, it can be confusing, I guess, if you look at the examples where um, some of the problems seem like they have, just basic f of x problems. That makes sense. And some of them have the derivatives. But you have to take into account, what it is the problems of, finding. Like for example, this particular problem, we're using the derivative, where and the reason is that if you remember the derivative of p of x, and in this case, the derivative of p of x allows us to find marginal profit. So for this particular problem, it's saying, given p prime of x, or the derivative of p of x, it wants us to approximate the total profit when 300 members are enrolled by computing and it gives you a lot going on there, guys. But I don't want you to overthink these types of problems, especially when you have a graphic. What you are doing here is you are finding, let's see if I can write this down. My computer wants to act up every once in a while. What you're finding is the area under the curve. Okay? Guys, we know geometry. And if I zoom in to this picture here, what I'm doing is I'm actually approximating. We haven't gotten to the point yet where we're finding the exact area under the curve. We're approximating the area under the curve at this point. And what we're doing, or what we're about to do, is we're going to find the area of this rectangle, the area of this rectangle, all the areas of each one of these rectangles, each one of those individual rectangles. We're going to add them together, because if you notice what they have in yellow, that would be the area that I would find. And the reason I'm saying I'm approximating the area, that's because there's a little piece of area here that's left under the curve. We're finding the area under the curve. There's a little piece that's left there that, we didn't find the area of. But can we agree? There's a little piece. Can we agree that um, it would be close to the actual area under the curve, that it's just not, as precise? And if you guys can follow with me for a minute, just think about it. What would happen if I were to make those rectangles a wee bit smaller? If I cut it in half here, do you guys see that if I were to make smaller rectangles, I could cut out some of that area? So as you work through these problems, I want you to understand that the smaller the rectangles, the more precise that area is. But I don't want to jump ahead too far. For this particular problem, I want you guys to understand that all we are doing is finding the area of each one of those individual rectangles and adding them together. How do we find the area of a rectangle? Your area, and it's just that simple. Don't leave just yet. My pen is acting up. The area of a rectangle is equal to base times height. Okay, now let's look at this problem. This is telling me, let's go back and get some information. I need to know what the base of, let's use this first rectangle for an example. I need to know what the base of that rectangle is, and then I need to know what the height of that rectangle is. Do you guys, well, they tell us in the problem that delta x, the difference between each one of these x values, is 50. So that's telling me that at this first point here, that is 50. That's at spot 50 on my x-axis. So I'm going from 50 to 100. So in other words, the length of the base is 50. Now the height of the rectangle at that point. They didn't really give it to me, but what I know is this red point that I have there, okay, that red line, it's starting at, or it's at x equals 50. But I need the y value. The y value is going to be f of 50. So what I would do is plug in 50, or not, I'm not using f. Let me use my proper terminology here. I'm using, what I would have to do is find p prime of 50 for this particular problem. So the area of that first rectangle is going to be the base, which is 50, and the height, which I have to find, is going to be found by plugging 50 into that function. Okay, so let's do that for each one of these. Okay, I have to take my time, and I can't zoom in. So let me come, it don't want me to zoom in too small while I write. It wants to zoom out. But if I want to find the area, I'm just going to make this as simple as possible. All I'm finding is the area. So I said that that first area is going to be found by doing my base, which is 50, times my height, which is going to be found by plugging 50 into the function. So that's going to be my first one. So right there, my second height, that the height is the hard part. Each one of these is going to have a width of 50. And I know I'm erasing a lot, but you got to remember I'm adding each one of these areas together. So each one of these bases is going to be 50, but the height, you're going to find the height by finding p prime of the x value. And where I have that second mark, that's at 100. And so plus, so I found this first one, the second one, this third one is here, that rectangle starts there. So the width is 50, and the height is going to be p prime of 150 plus 50. That's supposed to be times. I'm writing too fast. Times p prime of the height here is 200 plus 50 times the height here is going to be found by plugging in 250 inside of that equation. So again, to find p prime of 50, all I have to do is take 50 and plug it into the equation that it gave me up there. Now, that's a lot of math, but I'll be honest with you, all I did is I plugged it into my calculator to get those values, and I don't know if I have it right here. Let me go to my table set. I tell you what I did is I took that p prime of x and I put it in y equals, and I changed my delta table to 50, and I told my table to start at 50. And in my table, I found my values really quickly. So I could look at my table, go away. I could look at my table and see that my p prime of 50 was that 3,592.5, and then plus 50 times, I'm putting parentheses in the wrong place. The second one is 7,960 plus 50 times, my calculator went blank. That's going to be 12,728 plus 50 times p prime of 200 is 17,520 plus 50 times p prime of 250, which is 21,963. And guys, I promise you that if you add all of that up, you're going to get that answer that they were looking for, because I just did it a few minutes ago to check myself, was 31,881.25. So again, guys, all we did here was find the area under the curve.